All right, in today's video, we're going to be doing 2.3 quadratic equations in variable. All right, so we're going to be talking about different in quadratics. There's the factoring way that doesn't always work, but it works nicely if it does. We have the perfect square method, which always works. But then using the perfect square, we're able to develop what we call the quadratic formula, which also always works, which is, in my opinion, the best one to use. We're also going to be talking about a perfect square without factoring. And then, of course, we're going to be looking at some application. So that's pretty much like all that's throughout the book. Is just more examples of these types. Um, it does talk a little bit about how many real solutions and complex solutions, talking about the discriminant and stuff like that. But we're not going to, that's not something that we necessarily um, need to be able to do. Section. That's what you can see in your next math. All right, so to kind of get into it, we're going to start on page 125, and we're going to look at problem number 3. So we have x squared minus 14x plus 49 equals 0, and we're asked to solve the following quadratic equation by factoring. So we're just going to factor this, and then we're going to set the factors equal to 0 using the rule, the zero product rule, sorry. So again, we have the little t-chart going on. Technically, it's A times C, but in this case, we only have a C, so it's going to be a 49. And then our B is negative 14. Remember, this is what we are trying to multiply to, and this is what we're trying to add to. So you can go through all the multiples of 49, which I believe is just 1, 49, and 7 and 7. Because I'm multiplying to a positive and adding to a negative, that tells me both numbers would be negative. So you can negative 50, and this gives me negative 14. And this is what I am looking for. So a trinomial always factors into two binomials with the leading factor or leading term as x, and then you just bring in your factors that you came up with, in this case, minus 7. So then you take these factors to take it one more step further. One, as you set up 0. So then I'd add 7 on both sides, and I would get x equals 7 and x equals 7. Now, in this case, x equals 7 would be the only answer, and you'll have to write it down twice. So that's how we solve by factoring. Let's look at number 12. Number 12 is 4x squared minus 9 equals 0. When dealing with a binomial, remember the goal is to see, does it have a perfect square or a perfect cube? Meaning, can I take the square root of it and get a solid number, or a cube root of that number and get it? And hopefully the fact that you see a square, the only option we have is to see if we have a perfect square. Remember, it's called a difference of squares. So not only has that to be perfect squares, but make sure it's minus sign too. So it has to be in this form right here. So then I can break it down into this form. So this binomial squared into two binomials. And then I just take the square root of the first term. So the square root of 4x squared would be 2x minus plus. You can also do plus minus, it doesn't really matter. And square root of 9 gives me 3. So this right here would be your two factors. So then you would say 2x minus 3 equals 0, and 2x plus 3 equals 0. Again, none of them are 0, then multiplying it by 0 would get me 0. So it could be either or both of these. Well, it can't be both. It can be either or of these answers. So I'm going to add 3 on both sides. So that gives me 2x equals 3, then divide by 2. So I get x equals 3 halves. Here I'm going to subtract 3, and then I get 2x equals negative 3 divided by 2. So x equals negative 3 halves. Or there's your answer. So 3 halves and negative 3 halves. Right, and again, that's just a process of using factor. The next part they want you to be able to do is to take solve it by the square root method. So looking at number 13, you can be given something like this. The goal is you can basically, if you can isolate the square, then you can solve it that way. So if I isolate the square root of it. All righty, there we go. So sorry about that. So again, after you take the square root, um, you would have the plus or minus there because again, 3 squared would be 9 and -3 would be 9. So we don't know which one it would be. So what we're going to do is we're going to split this up into two situations. So it'd be x minus 3 equals 3, and then x minus 3 equals -3. So those are your two situations. And then we would still solve them the same way, add 3 across the board there. But in this case, 3 plus 3 would be 6. And then -3 plus 3 would give me 0. Let's try another one. Hopefully without interruption on that part. So on number 18 here, we have 9 equals the square, the parentheses, 3s plus 2 squared. So to get rid of this square, again, it's isolated. We would just take the square root. Remember, when we take the square root of the other side, it has to be plus or minus. So square root of 9 is 3. So again, this would be plus or minus 3. The square and the square root would cancel. You have 3s plus 2 equals this. Separate your two cases. So 3 equals 3s plus 2. And then -3 equals 3s plus 2. I'm going to subtract 2 on both sides. So 3 minus 2 is 1. And then I'm going to divide both sides by 3. So 1/3 equals s. Over here, I'm going to subtract 2. And so -3 minus 2 gives me -5, 3s, and I'm going to divide by 3. So I get -5/3 equals s. There's your two answers there. And that's just a way that we could use the square root method. The next process you need to be able to do is the completing the square method. So we have u squared plus 10u plus 9 equals 0. So in this situation, the best way to do this is I'm going to rewrite the first two terms, but I'm going to move the constant over. And when I do that, I get -9. So I subtract 9 on both sides. Now, the reason I kind of left this blank is after you do that, you want to add a blank to both sides. The goal here is to try to make it look like a problem that looks like this, where it has parentheses with a square. So to do that, I got to make this a perfect square trinomial. And the way to do that is I need to add the same number on both sides. So regardless what the number is, I'm going to do the same thing on both. So the way we get these lengths here is you would do b divided by 2 squared. So in this case, this is a, b, we don't have a c. So I would take, in this situation, 10 divided by 2, and I would square it. So half of 10 is 5, and then 5 squared would give me 5, right? So if I add 25 here, I can add 25 here. Now, the sole purpose of doing that is that this trinomial will automatically turn into a single binomial squared. Technically, it's still two binomials, but it'll be the same one. It'll always be a u, and then it'll always be just b divided by 2. So in this case, just n divided by 2, which in this case, it's a positive 5. So if I was to take 2 plus 5 times 2 plus 5, I would get this outcome. After that, do the work over here. So negative 9 plus 25, that would be 16. Once you get it in this form, now you're back to sum. So we take the square root on both sides. Don't forget the plus or minus. So I get u plus 5 equals plus or minus 16. And when I separate this, I get u plus 5 equals 16, and u plus 5 equals negative 16. So I'll subtract 5 across the board. So I'd get 11, subtract 5, and I would get negative 21. So there's your two answers there. Hold on. Oh my goodness. All right. It's the only bad thing about not having face-to-face classes. Square root of 16 is not 16. It is 4, plus or minus 4. So I need to have a 4 here and a negative 4 here. So this would be negative 1, negative 9. I was about to say those numbers look awfully big for something like that to work. So this would be negative 1 and negative 9. Again, helps to make sure you actually do the square root of 16. But there you go. But once you get to this part, it's the same process as the square root method. All right, once you have the complete and the square part down, then they lead into the quadratic formula, which actually does come from complete and the square. And if I had that kind of time, I would definitely show you a whole proof on how we got from complete and the square to the quadratic formula. Curious if your book does it. Sometimes they do, and they do. So if you go to topic 4 on page 119, they explain how they start with a standard form quadratic using complete and the square and how the quadratic formula. So some mathematicians saw a pattern and realized that they felt like they were doing the same process every time, and then just plugged in letters and realized, hey, there's an actual formula that will work every time as well. And so that's what I'm going to introduce here. So on problem 34, we are given 4x squared minus 3x equals negative 1. The quadratic formula is as follows. Negative b plus or minus the square root of b squared. Very important. Okay, just making sure you're back. All right. So very important here to divide everything by 2a, including that negative. That means it gets dropped. So try not to do that. Or we can actually utilize the formula of ax squared plus bx plus c equals 0, so that we can just pull the coefficient and plug it in. So in this situation, I have 4x squared minus 3x, but the negative 1 needs to be moved to the left by adding it. So this is now plus 1 equals 0. What's in the correct form? Just label your stuff. A is equal to 4, B is equal to negative 3. Signs go with the number, and then C is equal to 1. Once you have your value, simply plug it into your equation. So x equals negative 3 minus, and sorry for the technical issues now, and the square root of negative 3 squared minus 4. All right, hopefully it'll stop doing this. But minus 4 times 4 times 1, all divided by 2 times 4. This is just an order operation. Out your parentheses, your exponents, multiplication, division, all that stuff. Two negatives here make a positive 3. I got to do the exponents before I can do any subtraction, and I got to multiply before I can do any subtraction. So negative 3 squared gives me a positive 9. 4 times 4 is 16, times 1 is 16. And then 2 times 4 is 8. And then we kind of keep going. So now I can do 9 minus 6, which is 7. Negative 7 divided by 8. Now here we can't have a negative exponent, so this is where you pull out that I. So I'm going to do 3 plus or minus I square root of 7 over 8. And again, I like it like this better than having the I over here. You do not have to worry about writing this in complex form, which is the A plus BI. We can leave it just like this when you utilizing the quadratic formula. And let's do quite a bit more of these. So let's look at number 35. We're given 3x squared minus 4 equals negative x. So to get in the proper form, I'm going to add the x over. And notice I put it in the middle of these two terms to make sure I write it out in standard form, which again is highest exponent to lowest exponent. And I got it equal to 0. Then I always like to label A equals 3, B equals 1. If there's not a number there, it's imaginary 1. And then C equals negative 4. Remember, the sign goes with the number. So again, the formula was negative B plus or minus the square root of B squared minus 4AC, all divided by 2a. So when I plug this in, this gives me negative 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 4. All divided by 2 times 3. This gives me negative 1 plus or minus 1 squared is 1. 4 times 3 is 12. 12 times negative 4 times 3 is 12 times 8 times 3 is 6. Then give us a negative 1 plus or minus 1 plus 48, which is 49, divided by 6. Square root of 49 is 7. All right, so parts, they give us a whole number. Nice factored answers here. So again, but realize that quadratic formula works every time. But on that previous question, factoring would not have worked on that one. All right, so definitely let's look at number 39. Then we're given 3x squared minus 2x plus 0. Since we were asked to use the quadratic formula, any type of factoring. So in this situation, I would have a equals 3, b would be -2. Since I do not have a constant in the missing term, I represent it with 0. So again, formula, -b plus or minus the square root minus 4ab by 2a. So then I get -2 plus or minus -2 squared minus 2 times 3. Right. And I can separate these two problems. I have to make whole numbers here or a number. 2 plus 2 over 6, and then 2 minus 2 over 6. So this will give me 4/6, which is 2/3. This will give me 0/6, which is just 0. So there you go. So that again using the quadratic formula. Let's do one more to make sure you get plenty of examples. Let's look at number 40. 40 has 6x squared plus 5x minus 4 equals 3x minus 2. And get this the standard track 3x, trying to keep everything lined up, and add 2. So again, I'm going to get rid of all this by doing the opposite operation and then bringing it to the other side. So then I get 6x squared plus 2x minus 2 equals my 0. And so then I can see, well, a equals 6, b equals 2, c equals -. So again, the formula is -b plus or minus. Times negative and 24. Two is positive 8. So I get -2 plus minus 82 over 12. So in a situation like this, this is where the factor tree comes in. 2 times 26, 2 times 13. I can pull a 2 out. So then I get -2 plus or minus 2 square root of 13 over, well, that is step 5. Not in the wrap. You can see that 2 have a 2 in common. So I can divide every term by 2. -2 divided by 1. and then this 2 would technically cancel each other out, and I would have just a 13, and then 12 divided by 2 would be 6. In this case, the answer would be -1 square root of 13 over 6. All right, like the rest of the sections, there are definitely some word forms, so let's process through those. Let's look at number 68. So it says, how long would it take for a ball dropped from the top of a 144 building to hit the ground? So we have 144-foot building. We just want to see how far it hit the ground. So if you go back to the topic 5 on page 23, there's a formula there which says h is equal to -1/2 times g of t squared plus v naught times t plus h naught. All right, so h represents the height at time t. So we're looking to see when the height in this case is 0 because it hits the ground at -1/2. Gravity, since it was given to us as feet, we need to use, there's 2 of them. They give you a feet per second and a meters per second. So we're going to be using the feet per second. So that's going to be the 32. So again, gravity is given to you as 32 feet per second squared and 9.8 meters per second squared. So since this building was 144 feet, we keep the units the same. Times t squared, well, we don't know time. We're trying to figure out how long that would take. Initial velocity. Let's see, what did it tell us? So it said, how long would it take for a ball from the top of a 144 building to hit the ground? It doesn't have an initial velocity, so that seems to tell me that the velocity of the initial would just be 0. It's just falling due to gravity. So v0 would be v would be 0 times t plus the initial height, which was 144. So when we kind of clean this up a little bit, negative of 32 is -16 t squared plus 144. And so there you go. So the biggest thing is knowing this formula and knowing what everything is. This is gravity. This is just time. This is your initial velocity. And this is your initial height. This is your ending height. Ending height. Gravity. Gravity. Time. So then after that, and you plug it all in, then you're just solving at that point by any method that you would like. And since I can isolate the square root, I'm going to use the square root method here. So I subtracted 144, divided by -16. That'd give me +9. Then I take the square root, and I can forget the plus or minus, but I get plus or minus 3t. With a word problem, you have to realize that you cannot have negative times. That means that, so you have -3 and 3. -3 cannot be an answer. So in this case, this would be 3 because gravity is measured in seconds. So it take 3 seconds for, what was it? A ball to hit the ground at 144 feet. All right. Let's definitely look at a couple more. Let's get 69. It's very close to what we just did. So suppose that instead of being dropped, as in problem 68, a ball is thrown upwards with a velocity of 0. So remember, we have our initial height here is 144. This time we have a initial velocity of 40. I realize this is all feet, and this is feet per second. from the height of 144 feet, assuming it misses the building on the way back down. How long after being thrown will it hit the ground? I'm looking when height is equal to 0, so what is the time? Again, we use that formula of h equals negative 1/2 g t squared. I always forget if it's a plus or a minus. I think it's all pluses. Yep, okay. Plus the initial velocity t plus initial. So then again, gravity here, because it is in feet, we'll use the 32 feet per second squared. Or is it feet squared per, yeah, feet per second. Just plug it in. So we get 0, negative 1/2, 32, t squared plus 40, t plus 144. So when we clean this up, this gives us negative 16 t squared plus 40t plus 144. So we recommend the quadratic formula. So again, that's negative e minus we're back. We use the quadratic formula. So just a problem divided by you get negative 40 plus or minus 40 squared minus 4 times negative 16 times 144 divided by 2 times negative 16. Again, 4 two negative numbers possible bar. Here. I'm going to do 4 times 16 times 144. I get 9,216 divided by negative 32. Add 1,600 to that. 10,816 divided by negative 32. Man, I ran out of room. So I'm going to finish this process over here. I get negative 40 plus or minus. Let's see if that's a perfect square root. It is. It's 104. Nice. All right, so then we split that up into two numbers. We get negative 40 plus 104 divided by negative 32. And then we get negative 40 minus 104 divided by negative 32. So this answer would be 104 minus 40, which is negative positive 64. Divide that by 32. I'd get negative 2. And over here, I would get 104 plus 40, which is 144 divided by 32. Those would give me positive. So that'd be positive 4.5. So again, this is a real life problem. So we cannot have negative time. So it must be 0.5 seconds. All right, let's do one more. And I feel pretty confident that y'all have everything that y'all need. So let's look at 71. So the rock is thrown off a cliff with a velocity of 20 meters per second. So we have initial velocity of 20 meters per second. It is thrown upwards from a height of 24 meters. So the initial height is 24 meters. And misses the cliff on the way back down. When will the rock be 7 meters from the ground level? Now h is equal to 7. All right, and so we still want to know what time is. Our gravity in this case will now be 9.8 meters per second squared. So again, utilizing this formula. Nope. T. This is the H naught. All right, so then we plug it in. So this will be 7 this time. Negative 1/2 times 9.8 t squared plus 20 t plus 24. All right, so we have 7 equals 9.8 divided by 2, negative 0.9. All right, so then I have 7. And that would give me 17. Yep. All right, so then from there, I see that A is equal to negative 4.9, B is equal to 20, C is equal to 17. When I plug it into the quadratic formula, I would get negative 20 plus or minus 20 squared minus 4 times negative 4.9 times 17 divided by 2 times negative 4.9. All right, so I'll work this out. We'll do a lot of this real quick. So that's 400. And then this is going to be positive as well. So it's going to be 17 times 4.9 times 4 plus 400. And then we're going to take the square root of that. U. Roughly, it's roughly 27.08 divided by 49 times 49 it would be almost 100, so that's 98. So that should be negative 9.8. Give or take. All right, and then so from there, I'm going to take that answer and I'm going to separate these two. So negative 20 minus 27.08 over negative 9.8. And then this would be negative 20 plus 27.08 over negative 9.8. So so here is my answer. I'm going to actually add 20 to that. And then I'm going to divide that by 9.8. I actually get about 4.8. And over here, I'm going to do the 27.08. I'll do the rounded. Take away 20. Divide that by 9.8. And the answer will be negative. So it'll be about negative 0.72. Can't be negative, so it must be 4.8 seconds. All right. So that's pretty much it when it comes to quadratics. So that should be everything that you need to know to be successful in this section. But as always, if you need more examples, please reach out by email and I will definitely assist with that. Other than that, I will see you in the next video. Bye for now.